We're sticking with inverses. Yesterday, we were supposed to look at inverses of linear functions. They're really easy. You switch the x and y and you solve. But it's linear, so there's nothing tricky. It's like two-step equations that you learned how to do in 7th grade. Okay? Now, today we're going to look at some of the other functions we've studied. We're going to look at cubics today. But we've already solved cubic equations. So these aren't hard either. Inverses aren't difficult. All right, so if we were to solve this equation, which we already have, what undoes a cube? How do we solve when we have a cubic? We have to take the cubed root. So if we have a cubic function, then the inverse would be taking the cubed root. All right, so if we consider these two functions, f of x equals x cubed, and the inverse of f is the cubed root of x. Let's sketch these and see how it looks. So if we cube these numbers, we get -8 here, we get -1 here, 0, 1, and 8. Those were the moves we did when we graphed cubic functions. Y'all remember those? Okay, so we're going to do this one in blue. And we'll graph this pretty function here. 1, 2, 3, 4, 5, 6, 7, 8. And then you can probably do a better job than I can, but this is what this one looks like. So when we go into the cubed root, these were our moves for a cubed root. And we said the cubed root of -8 is -2. The cubed root of -1 is -1. 0 is 0, 1 is 1, and 8 is 2. That looks like a 6. That was supposed to be a 0. Okay, so we go to graph this one, and it looks like this. Once again, y'all are probably better at drawing these. I'm not good on them, maybe. Now, dealing with inverses, what do you notice about what's going on with the x's and y's in these two tables? What happens to our x's and y's? They switch. So, whether we're dealing with a linear function or a higher power function, when we look at its inverses, those x's and y's switch. And because of that, anytime we graph a function and its inverse, you're going to notice it reflects right over the line y equals x. If we folded it right down this middle, which I'm not good at drawing. That's better. Do you see that if I folded it down that diagonal, the pink and blue would flop right on top of each other? Got it? All right. Okay, so we're going to use that same method that we meant to use yesterday to find an inverse. So what were our steps? Step 1, switch the x and y. Step 2, solve for y. And step 3, rewrite in inverse notation. So what do I mean by that? That means if you started off with a y equals function, the inverse you would write as y inverse. If we started off in function notation, f of x, we would rewrite f inverse. So inverse notation just means denote that it is an inverse by using that exponent of -1. Now, that means something different than if I gave you straight out this. If I gave you 3 to the -1, that would just be 1 over 3. But in function notation, that little -1 means inverse. So those, they have different meanings because we're using them differently. All right. the x and y with a function, it also switches the domain and range, doesn't it? Because domain represents our input, which in the original function are our x values. Range represents our output, which in the original function is the y values. But then I go switching the x and y, and because I switch the x and y, I also switch the domain and the range. Now, with a cubic function, we just graphed it, domain is not restricted. Domain is from negative infinity to positive infinity. So is the range. So when I switch those, I can't even tell anything happened. So with cubic and cubed root, because they're inverses of one another, the domain or range doesn't get restricted. It stays negative infinity to positive infinity. Now Monday, we're going to look at some functions where that does matter. It didn't matter with linear either, because with linear, domain and range are both negative infinity to positive infinity. But on Monday, we're going to look at squares and square roots, which are inverses of one another. And then we have some issues. Okay. So let's look at number 1. So if we follow our steps, step 1, switch the x and y. So x equals y cubed minus 5. Add 5 to both sides. Now how do we get rid of a cube? How do we undo cubing? What is the inverse operation of cubing something?
Cube root.
Taking the cubed root. Now, we don't have a sign issue when we take the cubed root, because the cubed root of a positive is a positive, the cubed root of a negative is a negative. We don't have to worry about signs with the cubed root. So that stays the same. And then all we do is write using inverse notation. Questions? Okay, let's move on to number 2. Follow the same steps. Switch the x and y. Now this time, y is grouped in these parentheses. So I'm going to move the 8 first. And then when I take the cubed root over here, what I end up doing is basically freeing up these two. The cube and the cube root cancel, so that what I'm left with on this side is now y minus 1. They're no longer grouped, which makes it nice because now I can move the 1. And when I move the 1, I have solved for a y. So this becomes the cubed root of x minus h plus 1 is equal to y inverse.
So if you just like distributed the cube root, so you cubed everything instead, would that work still?
It would be much more difficult because to cube it, remember when we cube, that would give us this line of Pascal's. So it would, if I actually cube this, it would break down into,
Really?
and that would be much
Oh.
more difficult to
Well, what I
solve
did was
for.
I just-
So,
okay.
yeah.
I did something completely different.
All right. So now let's try this one. We have something being multiplied out in front. So slightly different approach, not much different. So step 1, still switch the x and y. But now when we go to solve for y, we can't take the cubed root yet because this isn't by itself. We have to get rid of this fraction. So when we have fractions, we multiply by the reciprocal. So now we have 2x. So that's what we have to do first before we take the cubed root of both sides. So now we have the cubed root of 2x equals y minus 1. Add 1. And we have solved for the inverse. Okay, you try number 4. Let me know if you have a question. So step 1, switch the x and y. Step 2, solve for y. So this one, to solve for y, the first thing we have to do is subtract the 10. Now the next thing we do is divide by 2. So, or multiply by the reciprocal, whichever way you thought about it. So if we divide by 2, we have to divide everything over here by 2 and everything over here by 2. So this one looks like this. You could either make it 1/2 x minus 5 okay, and or you could have made it x minus 10 all divided by 2. Either way. And then we take the cube root of both sides. And so we get the cube root of 1/2 x minus 5 equals y plus 2, which is the cube root of 1/2 x minus 5 minus 2 is the inverse. Or, like I said, you certainly could have left it this way. The x minus 10 divided by 2 minus 2 equals the inverse. I actually kind of like the second way better because the second way you can see what's going on. Do y'all see this divide by 2 actually causes a horizontal stretch by a factor of 2 because x is being divided by 2? And written this way, we can see the horizontal shift too. The horizontal shift is right 10. This way we can't. We can't see it. It has to be written like this. Any multiplier has to be factored out, which that's what we talked about fraction bars act as grouping symbols. It's really that 2 factored out, that 1/2 factored out. Dividing by 2 is 1/2 factored out. Okay, so now let's look at the other type. We're going the other way. So all of these, we're starting with cubics, and so we'll end up, we're starting with cubed roots, so we'll end up with cubics. Okay, so same steps, so to find an inverse, always the same. So we get x equals the cubed root of y plus 2. So x minus 2 equals the cubed root of y. Now this is what we have to be careful about. To solve for y now, I have to cube both sides, which means I cube everything over here and everything over here. We have to cube everything on both sides at this point. So cube, cube. So this becomes x minus 2 cubed. All right, is the inverse. Let's think about this too. This is kind of cool, guys. Do you guys see that this one would start by shifting up and the starting point would be 0, 2? Do you guys see that this one would start by shifting right and the starting point would be 2, 0? Does that make sense? Did the x and y switch? Yeah. Okay. So we should notice that that's going to occur every time. And that would be our answer. So for this one, we're going to switch. to, because it's just something being cubed, we're good. We can go ahead and cube everything on both sides. There's nothing to move. We can go ahead and cube. So we end up with x cubed equals y minus 4. And we're almost done. Add 4 and we're done. Let's see if this makes sense. The starting point of this one would be right 4. 4, 0. What would the starting point of this one be?
Up 4.
Up 4. So it's 0, 4. Beautiful. It does. It switches the x and y. Okay. This one. Same steps. We're going to switch the x and y, and then we're going to solve. Now to solve this one, the -5's got to move first. We have to have the cubed root alone. We have to have it isolated before we can cube both sides. So we're going to move that 5. And now we can cube every... Whoa, 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 whoa.
Why did you leave X?
I know. That's what I just noticed. I'm like, I got X's everywhere. This should be a Y. This should be a Y. That's why we had to whoa, whoa, whoa.
The only reason why I didn't call you out is because I went to the bathroom, so I missed a lot of it.
Okay.
I'm pretty sure.
You know I was wrong. All right. So now we're going to cube both sides. And so here we get x plus 5 cubed. And here we have y plus 3. And then we move the 3 over. And we are done. Oh! I'm just taking shortcuts everywhere. So, do we notice this starting point of the original equation is -3, -5. This starting point of the inverse is -5, -3. Beautiful. All right, so this is the last one we're going to do together, and then the rest of them are for homework. So what we'll do here is we'll switch the x and y. And then we solve for y. So we're trying to get this cubed root by itself. So what needs to go first? The 1/2 or the 3? The 3. Now, because this is a fraction, instead of dividing, we would multiply by the reciprocal. So we multiply everything on this side by 2 and everything on this side by 2. Everything. So this gives us 2x minus 6. Now we're undoing a cubed root. Cubing. Cubing. So this is cubed. Actually, I'm gonna take this back to where it was just a second ago. And I'll explain why in just a minute. And then you move the 1 back over. Now, I would certainly accept the answer this way, but I left it like this on purpose because you have to have any coefficients factored out to see your starting point. Do you see the starting point would be 3, 1? What was the starting point here? 1, 3. Does that make sense? Now, if we had distributed this through, it's a little harder to see the 3, 1 because you have to have that leading coefficient factored out if there's any kind of horizontal stretch or compression to find the starting point. So, just wanted to show you that. And then, okay, so your homework is just to find the inverse. That's it. That's it. It's going to take like 5 minutes. Maybe you can find 5 minutes in a class today and not even have to take it home.